Continue the fundamentals of remote sensing, Unit 1. Remote sensing platforms. The vehicles or carriers on which the instruments, that is sensor, is carried out are called platform. In order for a remote sensor to collect and record the energy reflected or emitted from a target or surface, it must reside on a suitable platform away from the target or surface being observed. Okay. Platforms for the remote sensors may be situated on the ground, on an aircraft or balloon, or on a spacecraft or satellite outside the Earth atmosphere. A listing of the platforms is given below. Handheld. Some field instruments may be carried out in the hand and pointed at the target in the question. Then cherry pickers. A platform similar to the one used by electrical workers when serving the lamp light, etc. It allows a larger region to be viewed with a handheld instruments. Balloons. It is generally tethered and suspended over a target region and is useful for taking the repeated measurement of a small area using either a handheld instruments or imaging instrument, for example camera. Radio control models. Both fixed and rotary wing radio control models Both fixed and rotary wing radio control models have been used to carry the remote sensing instruments. Both wings and rotary wing radio control models have been used to carry the remote sensing instruments. This type of platform has gained recent popularity. Non-piloted vehicle with pre-programmed flight paths. Both fixed and rotary wing radio control models have been used to carry the remote sensing instruments. This type of platform has gained recent popularity. Non-piloted vehicles with pre-programmed flight paths that are controlled by GPS have also become available and provide a cheap and extended mission capability for remote sensing data acquisition. Low altitude aircraft. Low altitude aircraft. Ultra flights may be employed up to 5,000 feet with light payloads. Conventional aircraft can extend these to cover 15,000 feet. Jets and other pressurized aircraft can fly at higher altitudes. High altitude aircraft. Special planes like the U-2 space plane can fly at altitudes of 20 km in the upper atmosphere. At this altitude, the aircraft is stable and geometric distortion can be minimized. Operational expenses are higher. Okay. The space shuttle has flown many remote sensing missions at altitudes of around 250 km. Medium altitude spacecraft. Spot and Landsat orbit at approximately 700 to 900 km above the Earth and can provide wide area coverage at high geometric stability and high spatial resolution. Spot and Landsat orbit at approximately 700 to 900 km above the Earth and can provide wide area coverage at a high geometric stability and high spatial resolution. High altitude spacecraft. Geostationary satellites such as those that beam down weather images for the television orbit at 220,000 km and provide broad coverage at the core spatial resolution. Okay. Geostationary satellites such as those that beam down weather images for the television. Weather images चाहिए, then orbits at 20,000 km and provide broad coverage at the core spatial resolution. Platforms are broadly classified into three classes: ground-based platforms, aerial platforms, and satellite platforms. Ground-based platforms, that is ground-borne. Remote sensing platforms that position the sensor at the Earth's surface are called remote sensing platforms that position the sensor at the Earth's surface are called the ground-based platform. These systems are fixed to the Earth and the sensors are often standard tool used to measure the environment conditions such as air temperature, wind characteristics, weather salinity, earthquake intensity, etc. The ground-based sensors can be placed on tall structures such as towers, scaffolding, or building to elevate the platform. Ground-based sensors are generally less expensive to operate and maintain than aircraft or satellite sensors. Ground-based sensors are generally less expensive to operate and maintain than aircraft or satellite sensors. This type of sensing is mainly carried out for the laboratory work or some kind of experiment and simulation works. Then aerial platforms, that is called airborne. Aerial platforms are mostly sensors mounted on fixed wing aircraft through other airborne platforms such as balloons, rockets, helicopters can be used. Aircraft are often used to collect very detailed images of the Earth's surface and facilitate the collection of the data virtually over any portion of the Earth's surface at any time. Aerial systems elevate the sensor above the Earth's surface to increase its aerial coverage. They also allow aerial platform, that means एयरक्राफ्ट पे जो भी हम सेंसर्स लगाते हैं, ओके, एयरक्राफ्ट को प्लेटफॉर्म के हिसाब से लेते हैं, दैट मीन्स प्लेटफॉर्म एयरक्राफ्ट जो भी है उसे एज ए प्लेटफॉर्म हम यूज़ करते हैं. Okay, they also allow researchers to monitor very large areas of the surface which would be impractical with the ground-based sensors or impossible or dangerous to visit. These are used for weather data, archaeological studies, generating aerial photographs, photogrammetry, etc. Various airborne platforms include balloons. Balloons are rather inexpensive platforms and offer a great variety of shapes, size, performance characteristics. They provide large field of view and require very less manpower. They have low acceleration, hence delicate the instruments can be mounted on it. They also exhibit low vibrations. There are three types of balloon systems. Free balloons. Free balloons can lift thousands of kilograms of scientific payloads and can almost reach the top of the atmosphere. Unless a mobile launching system is developed, The flights can be carried out from a fixed launching station. In India at present, Tata Institute of Fundamental Research, Bombay has set up a national balloon facility at Hyderabad. Then tethered balloons. Tethered balloons. These balloons have the capability of keeping the equipment at a fixed position for any desired length of time and thus for many remote sensing programs. These balloons have capability of keeping the equipment at a fixed position for any desired length of कोई भी टाइम के लिए हम वो इंस्ट्रूमेंट को इक्विपमेंट को बलून पे रख सकते हैं. ओके, at a fixed position for any desired length of time and thus for any remote sensing program. Powered balloons. These balloons require utilization of some means of propulsion to maintain or achieve station over a desired geographical location. Since these can be remotely controlled, guided along a particular path, they offer good potential as a platform for remote sensing application. Then aircraft. Aircraft have been playing an indispensable role in the development of the remote sensing techniques. The advantage of using the aircraft as remote sensing platform are high resolution of the data recorded, capability of carrying the large payloads, capability of imaging large area economically, accessibility of the remote area, convenience of the selecting the different scales, adequate control at all the times. However, due to limitation of operating the altitudes and range, the aircraft finds its greatest application in local or regional programs rather than measurements on global scale. Rockets. Rocket platforms are for one-time observation only. The data is collected with continuous change in range, direction, and illumination conditions. These are not of much use in regular operational systems. Satellite platforms. In space, remote sensing is conducted from the satellite. Satellites are launched for the remote sensing, communication, and telemetry, that means location and navigation purposes. A practical lower limit on satellite altitude of approximately 300 km is set by atmosphere drag. A practical lower limit on satellite altitude of the approximately 300 km is set by atmosphere drag. The upper limit on altitude is set by booster thrust capability and the gravitational field of the Earth. The upper limit on the altitude is set by booster thrust capability and the gravitational field of the Earth. Two types of orbits which have used in Earth application program are geosynchronous and stationary orbit, sun synchronous orbit. Okay. A geosynchronous satellite is a satellite located in an equatorial region, west to east orbit, with an orbital period equal to the Earth period of the rotation, that is 365 days. The altitude of such an orbit is approximately 35,900 km. The primary advantages of the orbit is that the satellite is stationary with respect to the Earth. This allows continuous viewing of that portion of the Earth within the line of sight of the satellite sensors. Disadvantages associated with this orbit include the extreme distance for the Earth viewing. Shortage of the spacecraft parking space due to orbital requirements and the need to have several satellites to obtain the coverage. Shortage of spacecraft parking space due to the orbital requirements and the need to have several satellites to obtain the coverage. And the synchronous orbit is an orbit selected so that the spacecraft passes over the same ground track at the same local time each day, and the altitude of such orbits ranges between 300 to 1000 kilometers. Since the synchronous orbit is near to the polar, it provides nearly global coverage. The advantages of this type of orbits lies in the fact that diurnal effects at given points along the track are missed. Advantages of the spaceborne sensors. Satellite permit repetitive coverage of the Earth's surface on continuing Satellite permit repetitive coverage of the Earth's surface on a continuing basis because of the design orbit. Gives high resolution with the synoptic view. Okay, can cover large area per second. Lower operating cost, covers area which are inaccessible. Consistent coverage with frequent visit can monitor temporal change. Okay, consistent coverage with frequent visit can monitor the temporal change, not constrained by flying condition or airport proximity. Disadvantages of the spaceborne sensors: cannot cover in cloudy weather except the microwaves. Initial cost is very high. Requires atmospheric and radiometric corrections. Creates large data for the storage. Requires expensive processing and analysis. Then restricted data cannot be used by the public, cannot be flown anywhere on the demand. The next one is application of remote sensing. With launching of Landsat 1 in 1972 by NASA, USA Spot by France and IRS by India, remote sensing technology has opened new vistas in the field of planning, surveying, monitoring and management of natural resources. It has provided easier technique to undertake effective and efficient mapping of land, water, soil, forest, okay, agriculture, urban area growth, flood plain mapping, crop acreage estimation. It has provided easier technique to undertake the effective and efficient mapping of कोई भी हमें एफिशिएंट मैपिंग किसी का भी मैपिंग चाहिए फॉर एग्जांपल लैंड वाटर सॉइल forests, agriculture, urban area growth. Okay, that means type for example sea water किस एरिया में है. Okay, then clean water किस किस एरिया में है पूरा एक It has provided easier technique to undertake the effective and efficient mapping of land. For example, land का mapping करना है, water का, soil का, forest कितने एरिया में forest फैला हुआ है, agriculture related कोई भी mapping करना है, urban area growth है, flood plain mapping है, कितने को कौन कौन से एरिया फ्लड में आते हैं, कहाँ पे फ्लड आता है, वो सब मैपिंग करना है. क्रॉप एकरेज एस्टिमेशन, दैट मीन्स क्रॉप एकरेज कितने एरिया में क्रॉप्स हमने ग्रो किए हैं उसका मैपिंग करना है. ओके, तो उस सब में क्या यूज़ होता है, रिमोट सेंसिंग. Some of the main applications of the remote sensing are land use and land cover mapping, agriculture, urban growth studies, ग्राउंड वाटर स्टडीज, फ्लड plain mapping, hydrology, geology and geomorphology, oceans and coastal monitoring, disaster management, etc. ये सब हम डीप में पढ़ेंगे ओके नेक्स्ट लेक्चर में। थैंक यू।